Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome to my channel where I teach you how to code. In today's video, I'm going to go through the updates that the HashLips Art Engine now has in version 1.1.2. You can click here on releases after going to this URL here at the top. Now if you go to the releases, you will see that we cover a few things. I covered that the metadata rarity has been updated, the Node.js version fix, a GIF as a preview, and something very special, which is generating metadata from nothing, basically from colors. So that's going to be super cool to show everyone. This video is an update for those who have used the HashLips Art Engine. If you are new and you want to know what it is, basically it comes down to taking layers and generating thousands of images for NFTs with metadata. Metadata is information about that image that OpenSea and marketplaces uses in order to display your images. That being said, if you want to follow along from the start, go to my YouTube channel under playlist and find this playlist over here. It's called Create 10,000 Generative NFTs, Artworks with Code. And that's exactly what it is. There's about 9 videos. This one will make it 10. And you can follow along with each iteration of each version. Now, I will be bringing out awesome videos on how to use the HashLips Art Engine from scratch. So if you want to wait for those videos, please do so. But stay tuned so you can see the latest update and what exciting new things you can now do with this art engine. As always, if you get stuck at any point, go to our website hashlips.online and go to our Discord community. Go and join and find out who can help out if you are stuck with any of the code that I show on these tutorials. Let's jump right in and see how we can get started. You will have to have Node.js installed on your machine, so go ahead and download that, as well as a great IDE such as Visual Studio Code. Once you have those two tools, basically jump back and go to this GitHub repo hashlips_art_engine. The next thing you want to do is click on version releases down here and search for the version 1.1.2. Now this is important that you follow along with the version that I show in this video so that the code matches exactly. Go ahead and download the source code over here. Once it's done, extract it and open it in your IDE Visual Studio Code like so. You will see that there's a folder structure, and the two main things that we need to worry about are these layers, which are basically the image layers, and I explained them in the previous videos very well. So I'm just going to show you this briefly. And then we also have the configuration file where we configure those layers and tell them how they need to produce images. What you want to do is run npm install here in the terminal, and if you don't have a terminal open, click here at the top on terminal and select new terminal. Now enter npm install and hit enter. This will actually install all the dependency needed for this program to run. Once all the dependencies are installed successfully, you'll see a screen like this in the terminal notifying us about a few warnings, which are perfectly fine. Then what we can do is run npm run generate. Once we do this, the program will load all of the layers, create a new build folder here at the top in just a second, and then start generating images from scratch. And there we go. We can see that we generated 5 images and we can find them here in the build folder now. We've got images, which looks like this, as well as metadata, which looks like this. Each metadata script, for instance 1.json, goes with 1.png. And it holds the information on how it was created and some extra metadata such as name, description, everything that marketplaces such as OpenSea uses. So in essence, what the HashLips Art Engine did for us was generate 5 images with metadata. Now we can up that, make it 20 images, make it 1,000 images, and just run the command in the terminal again. We will see that all these images gets generated, and there we go. Now we have 20. Let's look at the updates that was made so that you can use this in your projects. I have to say thank you to the community now, because it's the community that made these updates possible. The first update that I just would like to mention is that you will see this .nvmrc file, and this now specifies a specific node version, and this will resolve most of the node version errors that was popping up for some people. The next update is quite cool. If you want to know how rare your images are and how many attributes were used in the collection that you generated, you can run this command below, and you can type npm run rarity. Before, the rarity wasn't really calculated perfectly, but now the output is much more accurate. We can see that our trait type is selected, for instance, the bottom lid of our images. Let's go and take a look. You see this bottom lid over here? Well, we have a high, low, and middle, and in these traits we can see the trait, the weight that it carried, and actually the occurrences, how many times it showed up in the 20 editions that we generated, and giving us a percentage. This is a very cool addition and makes it a bit more accurate for you to see what's happening in your collection after you have generated it. Next, another addition to this HashLips Art Engine was rendering a preview image. Now before, if you ran the command npm run preview, if you did this, it will generate a preview image of the whole collection itself. Now, if we run in the terminal npm run preview underscore gif, what will be generated is actually a GIF image rendering each edition of this artwork for you. This is cool. Maybe you can use this in your collection or as a thumbnail for something. For the next update, I'm very excited. This is code that I've added to facilitate in a very special use case. Let's say you don't have the layers, but you already have thousands of images and you need to generate metadata for those images. So let's go ahead and actually remove all these things in the build folder. Now you can see I've got a clean folder structure in the build folder. We get the builds, there's no images currently, as well as no JSON. What I need to do is find some images. Now I found these images from Canva and it's pretty cool, so I'm going to drag this in here in my images folder. We can see that these images are food items. There's a carrot, some watermelon, a tomato, and a banana, and some hot dogs. Now, let's say we want to generate metadata and we want to generate it from nothing basically. We can go to our utilities tool and click on the generate underscore metadata file. Because we're going to generate metadata from something that doesn't exist yet, we need some kind of way to determine the metadata that we want. Let me walk you through what happens when we run this part of the code. This is experimental, and that's why I go into detail in this so that you can understand and adapt it to your needs. We start here at the bottom calling two functions. We do a build setup and then a start creating function. The build setup right here at the top basically just regenerates and clears out our metadata file for us. Then what we go and do is we go ahead and we run the start creating function. The start creating function is this one. And in essence, it just loads in all the images that you have placed in this images folder. Once it has loaded all the images, it redraws that image on a canvas and then it goes and saves the metadata. We can go and have a look here in the save metadata function what exactly happens. Basically, we grab the name from this image, so that's why it's important to have a sequentially named images such as 1, 2, 3, 4, 5, 6 and so on. Then we go and create a temp attributes array and we push some new attributes rarity to it. We'll get to that function in just a second. Lastly, we create a temp metadata which comprises of something of the configuration file such as the name and description and the image and so on, and then we concatenate the rest with the temp attributes up here. Lastly, we save this and there we have our metadata. We have to go and look at this add rarity function and see what it does, because this is super cool. Right off the bat, we can see that we're getting the width and the height of the canvas. Then we have a variable that's going to be our determining variable for our loop. We also have a counter, the image data, and these are all the images, all the pixels basically. Then from that, we actually get the RGB data, conveying all those single pixels. And then we have a new RGB variable, which we're going to hold and save on a later stage. We've got this tolerance field, which you'll see come into play in just a second. And then I have some test variables over here. You can see that I've got a rare color base and then the rare color. Now, this sounds like something from Silicon Valley, not a hot dog and a hot dog. But technically what we are trying to do with this metadata is try and find a way, how can we determine if an image is a hot dog or not? For now, we are going to use the average color of this whole image as the determining factor. I know that is not enough to go on to say if something is a hot dog or not, but at least it will help in certain cases where your colors are vivid and very defined and that your images follow a certain pattern. Now later on, like I said, we are going to refine this. We are going to add shape detection and all sorts of cool things. But this feature is too cool to not share with everyone at this very stage. Now, how do we get the determining values of each one of these colors? Let me show you how to train this program quickly and then let's run it. In order to make this work, we're going to do it in a two-part process. We need to calibrate these images to know what is hot dog colors and what is not. So now what we can do is basically in the terminal run this command, npm run generate underscore metadata. Once we do that, we will see metadata actually being generated, but it won't be correct. The reason is because we haven't calibrated what are hot dogs and what is not. Now the secret to this is to not calibrate all your hot dogs because calibrating thousands of hot dogs is redundant. We need to kind of only select a few and see if the program with the tolerance will pick up if it's a hot dog color or not. So now we can see that the RGB values was rendered and then some statement, but then the image. We need to now go to that image and see if it's a hot dog or not. We can see that our image is indeed a hot dog, but our program tells us it's not. So what we'll need to do is copy this very first line over here, then go back to the generated metadata file and go and replace the first value. Next, let's look at the second one. We can see that image 2 is a hot dog 2, and thus we can take the second one as well. I'm going to replace the metadata RGB calibrating in here. Then we have image 10, which was rendered. That is not a hot dog. 11, not a hot dog. 13, not a hot dog. So let's go and search for which ones are. 3 over here is, so I'm going to select wherever that was rendered, which was up here. Going to copy that and paste it in here. Now I'm going to try and only use 3 calibrating hot dogs so that I can see if the rest will be picked up automatically. That is our first calibration step. What will happen now is we will loop through all the pixels in each image, add to the count, and add to the RGB values. Then we'll divide everything to get the average value of each red, green, and blue value. Then we set our rarity color base to, this is the trait name, so currently we set it to the rare color base, which is the base, and the base is not a hot dog. Once we have that, we're going to go and loop over it, and then we're going to see if the neighboring color is indeed close enough with the tolerance, of a leeway to our actual calibrated colors. Once we have that, we are now ready to add to the metadata over here. And you can add as many metadata fields. Each field will contain a trait type and a value. So you will see if we run this now by running npm run generate metadata again, we will see the actual values that's going to be saved. Now we can see that if we go to the top of these logs, we will actually see that our first image is indeed now a hot dog. Keep in mind these images come in random order because it loads basically when the image has loaded, so some images might load faster than others. we can have a look at the first image and see that this is a hot dog. Let's see what its JSON says. The JSON has the name, description, and all those good stuff, but it also has the metadata fields, and under this trait type, what is this? It says it's a hot dog. The next image is number 2, and the JSON says it's a hot dog as well. 3, and we can see that this is a hot dog too. Number 4, hopefully this is a hot dog. And yes, this is a hot dog. Let's go and see what number 6 would be. If we go to the JSON, we can see that it considers this as a hot dog too. That's very interesting. Why is it doing that? Well, all of our images mostly consist of a lot of white pixels. And in order to get a more accurate guesstimate of what this is, we need to enlarge these images so that there's not that many white pixels. Otherwise, it would consider that as the actual average. To see if we can get better results, I've gone ahead and enlarged each one of these images. You can see that each one of these images takes much more available space, thus we can get a better average color. So what we'll need to do is run this one more time with the new images, then go and select each image, which is a hot dog, and then go and grab the results. So I've run it once more, and there we can see there's 110, but this is number 11, which is supposed to be a hot dog. I'm going to put this in there. Then I'm going to go to the next image until there's a hot dog again. There's 110. So let's go and grab that one. Let's put it in here. And then let's see 111. This is a hot dog too. So I'm going to grab that. Now that this is in place, let's run our program again and see the end result. We can also lower the tolerance, and let's lower it to maybe 7. Save it, run it again, and then let's check what we have. If we look at image 11, this is a hot dog, so our metadata also should reflect this. And indeed, this is a hot dog. Number 21 is a banana. And if we look at the JSON, it says this is not a hot dog. Great, we are winning so far. Next up, we have 31, which is a tomato, and we go there and we can see it's not a hot dog. 41 is an avo, and it also says not a hot dog. 51 is also, well, this one says it is a hot dog. So this is now a little bit, where things get a bit skewed. So what we'll need to do is lower the tolerance even more. So I'm going to lower it to like 3. And then once I've done that, rerun it, and let's see what does the watermelon tell us now. Not a hot dog. Perfect. And the rest is still a hot dog, not a hot dog, not a hot dog, not a hot dog. So it's getting a bit better. Number 61 is also not a hot dog, which is good because it's a cupcake. 71 is a gherkin, I believe, or a cucumber. So let's go and check. This is not a hot dog. 81 is a carrot, and this is not a hot dog too. 110, it's a hot dog. Perfect. 111, let's hope it's a hot dog, and it is. It will be interesting to see the very last one, what this could be. And it says it's not a hot dog. And that's because the color of this hot dog's dog actually is a bit more red than the others. Now, unless you add all the possibilities of the hot dog colors in there, so you have to do more calibration, you can do that and then rerun it. But in essence, this kind of works and generates and will cater for a very basic use case. Now we've got our images and we've managed to generate metadata for them. So for this edge case, this will cater to some degree. I urge you guys to go ahead and play around with this file. This is one of our experimental features and it would be great to see how we can flesh it out. I will be trying to add image recognition, shape recognition, so that we can really narrow down what we are trying to detect. But as a base, this is a starting point for you to see how you can amend metadata, add your own based on color variants. This will be interesting to see how you guys take it and what you come up with. This brings us to the end of the updates for version 1.1.2. Now I highly urge you guys to go and try it out, and like I said, if you struggle, go and join our Discord. I want to say thank you to the 23,000 subscribers of this channel. I really enjoy teaching you guys how to code and come up with these awesome concepts to use. If you liked how I explained stuff in this video, go ahead and subscribe and turn on the bell notification so that you are notified whenever I have updates or new content. Then give me a thumbs up if you enjoyed the content and let me know in the comment section what you thought and what you would like to see next. Till next time guys, have an amazing day.